Okay, welcome everybody. I'm Ed Sykes. I'm going to be presenting this research project entitled Enhancing Micro-Location Accuracy for Asset Tracking and Evaluation of Two Fingerprinting Approaches Using Three Machine Learning Algorithms. The outline of this short talk is as follows. So we're going to go through an introduction and then a background, methodology, findings, and conclusion. So first, the introduction. So this research is centered around, obviously, microlocation. And so what we're trying to do is look at different types of machine learning algorithms and different approaches to increase accuracy and reliability of the signal. In terms of background in this space, obviously there's been several approaches to improve the accuracy of microlocation systems, such as Wi-Fi based indoor location systems, RFID, even camera-based indoor location systems. However, what we're focused on in this research is using Bluetooth Low Energy, so BLE beacons. The machine learning algorithms that we used in our context need to address two different problems. First is regarding the variability of the RSI signals that are captured from the actual beacons. So that's the first problem. The second problem is the core of this research, which is essentially to develop a predictive system that will aid in discovering the precise location of a person or asset. So the first issue is, has been studied pretty extensively. How can we ensure the RSI signal that's being emitted by a beacon is as true and accurate as possible? So the one that we used and is fairly commonly used is the Kalman filter to ensure that the variability of the RSI signals is at a minimum possible. So we're trying to increase the degree of accuracy right at the very get-go in terms of the filtering the signals that are being received from the beacons in our environment. The second issue is surrounding, obviously, the prediction of the actual algorithm for determining the precise location of the thing. And in that part of the problem, we focused on three different machine learning algorithms or approaches. So the convolutional neural networks, so CNN, and then a multi-class decision forest and multi-class decision jungle. In terms of methodology, this is our methodology. So we looked at a number of different aspects surrounding a nice set of experiments we could conduct to test our algorithms and our approach in trying to increase our accuracy of the microlocation. So the first step is basically beacon placement and room configuration. Step two is these two different methods for microlocation called zones and XY. Those are two unique methods that we explored. Third is a new process for increasing microlocation accuracy, and materials equipment, high-level architecture, data collection strategy, and analysis techniques. So this is our environment that we use to deploy our beacons and to test our algorithms. The two methods that we use for microlocation, zones and XY. So the zone method essentially we suspended a beacon from the ceiling. So from the previous slide you saw our environment. So we suspended beacons at a number of these spots representing so covering a grid-like environment. You can see the dots on the floor there, and representing a 3D volume essentially of coverage. So that's the zone method. The XY method is slightly different. What it does is tries to get a really clear understanding of what the RSI signals are at a particular point in this room. So as you can see on the picture on the right, it uses a fingerprinting approach. We used a collection of these iPads and collected the precise RSI values for that particular spot in the room. So in terms of our process to increase the microlocation accuracy, this is essentially the high-level architecture, or a process, I should say. So the raw RSI values coming in from the beacon go through a Kalman filter, and then we use a moving average also to smooth the RSI values coming in. We then use those values for our fingerprinting process, which is RSI pairs of location and RSI values. And from there, of course, then we applied our machine learning processes, so as mentioned. In terms of our findings, Here they are. So for the zone method, these are the three different algorithms that we use. So the CNN, decision jungle, and the decision forest. As you can see, the mean are presented here, mean, median, max, and standard deviation. So the standard descriptive statistics are presented, and they are also presented here for the XY method. What's sort of to be noted here is that we were able to achieve an accuracy of less than 2 meter accuracy, which is the current challenge that many researchers are exploring in this space. So our approach broke that 2 meter radius of accuracy in pinpointing a thing, a person, or an asset. In terms of summary of the sub 2 meter accuracy, so when looking at these 4 metrics, so the prediction reliability, accuracy, prediction time, and deployment time. So the zone method, we were able to achieve a prediction reliability of 98%, and the accuracy of 1.77 meters, so that's the mean. And the prediction time is also quite rapid, so less than 2 seconds to achieve that level of accuracy. In terms of the fingerprinting aspects, of course, the deployment time. So the deployment time is the fingerprinting exercise, as well as, of course, setting up all those beacons in the environment. So that is around 7.5 hours. In terms of conclusions, so we created a prediction system for indoor microlocation environments using BLE beacons that consistently performs at an accuracy of 1.7 or less, spherical radius from the target in under 2 seconds, and was validated across 2,000 trials. Our system offers higher accuracy than other state-of-the-art systems, and what we did is we provided a generalized indoor microlocation system that can be easily and rapidly deployed to new environments. We believe this is a substantial improvement over the other systems that take days to collect fingerprinting data. And we provided a comparison of these two different data collection techniques using zones and XY method and the 3 learning algorithms that we investigated. Lastly, we contributed also by providing an architectural model by which other researchers can extend our work on microlocation. If you have any questions, please reach out to me. I'd be more than happy to discuss this research and other research that we do at the Sheridan Center for Mobile Innovation. Thank you.